Ever wonder why your favorite apps stay fast, reliable, or consistent, even when the internet gets messy? Enter the CAP theorem, the golden rule of distributed systems. It says you can't have it all: consistency, availability, and partition tolerance. You pick two and sacrifice one. In this video, we're unpacking the CAP theorem with real-world examples and practical tips to help you design systems that thrive. Let's dive in. FullStackDev crew. The CAP theorem, coined by Eric Brewer, is like the physics of distributed systems. It states that any network system can only guarantee 2 out of 3 properties: consistency, every node has the same data; availability, every request gets a response; and partition tolerance, the system keeps running even if network connections fail. You can't have all three at once. It's a trade-off that shapes every modern app, from Netflix to your banking system. Consistency means every node in your system sees the same data at the same time. Think of your bank account. If you transfer $100, every server must reflect that instantly, or you might overdraw. Systems prioritizing consistency, like traditional databases, ensure data accuracy, but may pause during network issues to avoid serving stale info. It's like a librarian who won't let you borrow a book until every record is updated. Availability ensures every request gets a response, even if the data isn't perfect. Picture Twitter. If a server goes down, you can still tweet, even if some users see your post a bit later. Systems like NoSQL databases, such as Cassandra, prioritize availability, serving data fast even during network hiccups. But you might get slightly outdated info. Like a coffee shop serving you decaf when they're out of regular, you still get coffee. Partition tolerance means your system keeps running even when network failures split it into isolated chunks. Imagine a global app with servers in the US and Europe. If the transatlantic cable breaks, a partition-tolerant system still functions, maybe with trade-offs. In today's cloud world, network partitions are inevitable, so most systems must prioritize this, leaving you to choose between consistency or availability. CP systems, like MongoDB and certain modes or Google's Spanner, prioritize consistency and partition tolerance. They ensure data is always accurate, even during network splits, but may reject requests if servers can't sync. Example: your bank's AMA. It might go offline during a network issue to avoid dispensing money based on outdated balances. Perfect for systems where accuracy is non-negotiable, but downtime is a risk. AP systems, like Cassandra or Dynamob, prioritize availability and partition tolerance. They keep serving requests during network issues, even if it means slightly stale data. Think of Netflix. If a server is cut off, you can still watch your show, though the recommendation engine might not have your latest views. Great for high availability apps, but you might see inconsistencies, like delayed updates. Banking systems, like those powering your online transactions, often lean CP/TI. Consistency is critical. If you transfer $500, every server must agree on your balance to prevent double spending. During a network partition, the system might pause transactions to ensure accuracy, sacrificing availability. That's why your bank app might show service unavailable during rare outages. Data integrity over everything else. Social media platforms like Twitter or Instagram go AP/TI. They prioritize staying online, even during network issues. If you post a tweet and the server is temporarily disconnected, others might not see it instantly, but you can keep posting. Availability keeps the platform alive, and eventual consistency catches up later. That's why your feed might briefly show old likes or comments. Building with CAP in mind? For CP, use databases like PostgreSQL or MongoDB with strong consistency settings, and sync via quorums. For AP, Cassandra, or Dynamob, with eventual consistency are your go-to. Tools like Zookeeper can help manage distributed coordination. Always test failure scenarios, network splits, node crashes, and monitor trade-offs with tools like Prometheus. Your choice depends on your app's needs, precision or uptime. CAP isn't a free-for-all. Misconception 1. You can ignore partition tolerance. Nope, networks fail, so you must handle partitions. 2. Consistency and availability are binary. In reality, systems like Spanner use tricks like Paxos to get close to both. 3. CAP applies only to databases. Wrong. It affects any distributed system, from microservices to blockchains. Know these to design smarter systems. The CAP theorem isn't just theory. It's the blueprint for building resilient apps. Whether you're crafting a banking system that demands consistency or a social platform that needs to stay online, understanding these trade-offs is key. Pick your priorities, test your systems, and build with confidence. Thanks for watching, FullStackDev fam. Smash that like button, subscribe, and let's keep designing systems that scale and survive.